In this question, we're given the weight of an object at 5 different distances from the center of the Earth. So we have the center of the Earth and a bunch of different distances. Now, it might be useful for us to, instructive for us to figure out what the height, what the radius of the Earth is. And we know that is 6.37 times 10 to the 6th meters. And so that's what this is right here. This first is at the surface of the Earth. And from there, it increases. From there, it increases. Double this distance would be 12.74 times 10 to the 6th, or 1.274 times 10 to the 7th. Oh, that's right here. So that is at a second distance. And a third, we would add another 637. So 1.90. Oh, that is the third distance. So if we just counted by 6.4s, rounding those off, 6.4s, this is 12.8. And this is going to be 19.2. And this is going to be 25.6. And the last one is going to be 32.0. So these, of course, move over because it's 10 to the 7th. So what we can see is each of these are a multiple. So that means what happens is we know that the weight of something is mg. And we know that the force of gravity is also big G, big M, little m over r squared. So we see these weights decreasing, and we now know that these are occurring at multiples of the radius. So this is A, this is B, this is C, this is D, and this is E. All right, so we get to the next question. The first question, what is the mass of the object? Well, we could go through some calculations using this formula with the mass of the Earth and the universal gravitational constant to find this using the R's that are given and the weights. So we could do that. Or, let's see, do we know, we're looking for the mass. We know a bunch of weights, but we know G is 10 here at the surface of the Earth. So if the weight is 1,000 newtons and gravity is 10, then the mass is 100 kilograms. And so the key piece here is, again, recognizing that this location is at the surface of the Earth, location A. So the mass in this case, if it was 1,000, the weight would be 10,000 newtons. Well, 10,000 newtons would have to be inside the Earth. 10 kilograms would be times 10 would be 100 newtons. And 100 newtons is about here. But the acceleration caused by gravity is not 10 there, and so on. So that's why it's the answer to this particular question, is number 3.